If I asked you to close your eyes and think about a robot, maybe you envision something like this. Maybe we want to think about robotics from a different perspective.
Robotics as a field really started in industrial settings where very precise and fast motion was needed. Those same technologies are not really suitable for interacting with people.
When we think of biorobotics, we really think of something that's more like the field of AI, of artificial intelligence. Thinking about that combination of both the body and the brain and, the group. There's just a lot of examples in biology where we can see how that can be achieved and how we can leverage the same kinds of ideas.
I think biorobotics is a new discipline connecting living creatures and robots.
Let's take a look at nature, see how nature does things.
Looking at design principles in nature and trying to build robots that either implement those principles or interact with those principles.
Looking at humans, looking at biomechanics, looking at the materials that exist in nature, looking at the algorithms that nature uses.
What is intelligence? What is the technology that's going to make us be able to understand what biology already has?
And hopefully it's not just inspiration but actually bio-informed, that we take what we learn from animals and use it in applying those techniques to our robots. Almost all locomoting robots and many of the manipulating robots are inspired by these soft animals that we're familiar with.
If we wanted to make a robot that acted some way like this, how would we do this?
So compared to more traditional robots, the things that are, welding the doors on your car in an assembly line, we're making robots which are inherently safer to interact with because they're soft or they're small, and because of their size or because of their compliance and ability to adapt to sort of natural environments, can perform tasks that are difficult or impossible with other classes of robots. Take, for example, the RoboBees project, which is the goal of creating a colony of autonomous robotic insects. There's nothing off the shelf which is going to be used for any of the components, and so we have to reinvent every feature of this robot, and along the way have new technologies that are developed as part of that.
Many of the people in our field are inspired by the incredible ability of biological systems to cooperate. If we think of swarms in nature, let's say you think of termites that build mounds, or you think of ant colonies that can forage over large regions. Imagine being able to create robotic systems that could do those tasks. So could I make robots that build? Could I make robots that could go through a coral reef and monitor the health of a system? If you think about traffic and self-driving cars, as soon as you have a lane full of self-driving cars, you have a lot of robots on the road. So if we can build an algorithmic understanding, how do you have large scalable collectives work together in a decentralized way? And they're going to be slightly faulty and they're going to have low capabilities, as opposed to the absolute perfect robot that can perfectly navigate through some complex environment. That's a really amazing manufacturing technology, right? Because you could mass manufacture simple things, and then those simple things would cooperate and create something of a much higher complexity.
What we are aiming at in robotics is really this concept that where humans and robots can coexist, can coordinate, can distribute tasks to the joint benefit of all.
As you know, there are many big differences between the driving mechanism of current robot and human body.
So we're working on soft wearable robots to both enhance and augment the ability of healthy individuals, and then we're trying to apply the same technology to people who have some kind of physical disability.
It's
Historically, when people have designed wearable robotics, they've tried to think about how do we give someone superhuman strength. What we believe is that there's a lot of people with some kind of disability who don't need superhuman strength, but just need a small amount of assistance. But that small amount of assistance can have a pretty big impact in their quality of life. So we're trying to take a new approach and say, how do we design new robotic components that are using soft materials to be able to apply forces to a person and without the mass and the kinematic restrictions associated with rigid devices.
There's a potential to really help people who have severe injuries.
It's taking an unconventional approach. You're not saying, okay, how do we improve on the status quo? It's saying, how do we basically take a fundamental leap?
We can push all these different fronts, but somewhere behind it there are core ideas that we can share, like how do you produce autonomy? What are the sensing technologies that could work? Can we make softer robots?
What we're trying to do is make robots smaller, softer, safer.
The line between person and robot get blurred even more, where people are interacting with robots in ways that they never imagined.
These are ways that will have profound impact on our lives in the future, and robotics will be at the forefront of that.
Robo-bees, octo-arms, even mechanical cockroaches. Every day, Robert Wood uses the natural world as inspiration for each of his new inventions, an approach known as biomimicry.
Nature's had hundreds of millions of years to evolve solutions to things like locomotion in cluttered areas or flight. If you come up with a task that you need a robot to do, you can look into the animal kingdom and find interesting solutions that you can draw from.
Robert is a professor of engineering and applied sciences in Cambridge, Massachusetts. He and his team at Harvard University's Microbiotics Lab are currently working on tiny robotic winged insects, known as robo-bees.
Our team is working on creating a colony of autonomous robotic bees. We envision that 20 or so years down the road, when these things actually exist, they could be quite useful for applications where you wouldn't want to put a human or an animal. Hazardous environment exploration, search and rescue, space exploration, assisted agriculture.
What I think makes our small robots unique is that if you are small, then maybe you can get into little nooks and crannies that other robots could not get into.
But first comes the challenge of building a robot the size of an insect.
By developing new types of robots, we have to develop all the core technologies from scratch. What we don't want to do is have hundreds of components that are the size of human hairs assembled under a microscope by hand. That would be very difficult. So we use origami as an inspiration for some of the processes that we've developed. So just like you would if you're folding a paper airplane, we do the same thing, but it's thin, resilient, strong plastics as opposed to paper.
And once Robert's creations are assembled, it's time to test them.
There's so many things that could go wrong with these tests and do go wrong with these tests. So a wing could break or a wing could fly off. The actuators could crack and fail or even catch fire. But the nice thing about that is if we are able to sort of extract all of the motion, we understand exactly what happened. We can back engineer what it was that made it crash such that maybe the next flight would be successful.
We build, we test, we build, we test. If you don't fail, you don't learn enough. We build, we test, we build, we test. For everything that works is tens or hundreds of things that don't.
So failure isn't really failure in that sense because we learned something.
And their patience pays off.
Oh, that's a beautiful flight.
With every failure, they get one step closer to building the next big thing.
This device happens to be one of the fastest robots on Earth, if you normalize to its body length. Twice as fast as Usain Bolt. We can change its gait, we can change how it's running, whether it's a trot or a run or a crawl. As these things get smaller, gravity starts to matter less. And so we can experiment with different ways to have them climb on different surfaces.
And his inventions may even reach us at home.
In our everyday lives, if I want a robot to help me in my home, if I wanted to cook me dinner, if I want it in my hospital, we want to do this in a gentle way. So if you want to interact with something that is very, very soft, well, one of the things you can do, make the thing that's gripping it soft too. So we designed squishy fingers for robotics.
So, whether it's with speed or maneuvering a delicate squeeze, robotics could soon change the way we go about our daily lives.
I think the most exciting thing about robotics now is how close we are to it really positively impacting our lives. Science fiction has been promising us a lot over the course of all of our lives. Now it's actually starting to come to fruition.
With DSX, we want it to be the window to the future.
What we're trying to do is change the prosthetics industry so we can offer affordable, functional, and beautiful prosthetic devices to amputees.
I'm proud of being one-handed. It doesn't make me feel any different. But wearing this, instead of having people come up to me or give me like the sincere look of, oh, you've lost your arm, they go, oh wow, this is fantastic. And I just like to see people have a smile on their face about it. That's what it's all about for me.
Because we're heavily promoting this kind of technology, some people really think like we were producing, augmented arms. And some fans or some moms and so on were asking, where can I buy your arm? And unfortunately, we have to say, we're not building any arms, we're just a video game company. But that triggers, the thing where we say, we should do something.
It was a really natural fit when they got in touch with us. We were almost expecting it at some point, and we formed this idea to try and turn Adam Jensen's arm into a real-life bionic limb.
I was actually only born with my left hand, so I've never seen any different, and I've always wanted to have like a robotic hand. I've never said I wanted two hands, just a robotic one, just to feel more cyborg, because it's just so much cooler, especially being into sci-fi and comics and stuff.
I developed the first bionic hand when I was 17, just tinkering in my bedroom at my parents' house when I was younger. So when I went to university a few years later, I wanted to take the project a little bit further and found that bionic hands existed for amputees to wear, but they were extremely expensive. And so I used that angle as an excuse to be allowed to create a bionic hand for my final year project at university. And then after university was when I co-founded Open Bionics, and we began working on the same problem with a more kind of definitive goal of being able to offer these bionic hands to people at a really affordable price.
So this is a custom built one for myself. We use sensors in the top and bottom of my arm. So if I tense my bottom muscles, it will close. And if I loosen up but tense upwards slightly, it will open.
We have a fantastic art director. His name is Jonathan Jack Beltet. This guy is a visionary. He's completely crazy. And the way we wanted to depict, a future world was that human augmentations couldn't be like just medical device. We wanted it to be super rewarding. People are wearing this kind of prosthesis in a fashionable way. For Deus Ex, we never wanted to do some gimmicky big robot's hand and so on. We wanted something to touch upon, the high fashion, very refined design, something that looks very slick and very, you could be very proud to wear it.
And then you can change all the functions like that. Kind of cool.
At this point, we've made a semi-functional prototype. So we've made one that's functional and looks similar to Adam Jensen's hand. The next steps for us will be perfecting the functionality of it so that it works really nicely and it's very good at grasping objects, and then making the finish really nice so that it looks the part as well. The design files that we're working on in this project will be open source as well, so people will be able to download them. If they have a 3D printer, they'll be able to make themselves an Adam Jensen arm that will be functional, and they'll be able to use it.
We don't want to cut this technology, this accessibility to people who have their both hands and so on. So we partnered with Intel with their RealSense division and Razer with their Stargazer division also.
Multiple points on the hand in motion is captured in real time. The result is a one-to-one mirroring between the user's hand and the bionic hand.
We want to show limb-different people that the products and devices that they're seeing in science fiction, in gaming and in movies can become reality, and can become reality very soon.
It's mind-blowing for a lot of people, but I cannot wait for the future of this.
Everything we're doing is somehow a new step forward. We now defining the future.